Good morning, everyone. My name is Kyle Lake. I'll be today's presenter for our webinar on how to perform schematic analysis from any design tool. All right, so thank you for attending this morning. Hopefully, we will cover enough for you to learn how to analyze a schematic for common errors from within the Mentor Schematic Analysis tool that I'll be highlighting today. Okay, so what's nice about this tool is that we are actually able to analyze a schematic from any design tool. Okay, so all we really need for this schematic analysis to run on your schematic is a bill of materials and a netlist from your particular schematic capture tool. So it doesn't really matter exactly what you're working with. I will be showing it today from within Xpedition Designer and some of the benefits that we can have if you're working with that environment. But do take note that it is able to work with, again, that bill of materials and a netlist from any schematic capture tool. Okay, so after we analyze that, we're able to just view and review those results, create a nice report for maybe design review purposes or to pass up to management. And also I'll be talking about how to set up the simulation model. So this does take simulation models into effect. Again, the bill of materials and the netlist will have all the schematic definition. And then we'll utilize the models themselves to actually capture the design intent of the components themselves. Okay, so we'll be able to look at how those components actually work, the input thresholds, the output voltages, and just verify that the schematic has been wired up to the correct voltages, the correct input outputs, those types of things. And I'll give us a brief list of the types of checks that we'll be checking within this tool. Okay, so again, my name is Kyle Lake. I am with Oasis Sales. I'm an application engineer covering the printed circuit board tools and simulation tools. And if you're unfamiliar with Oasis Sales, we are a premier Mentor Graphics, now a Siemens company, EDA partner. Okay, so and we have been for over 18 years. So we're really happy to continue to provide our customers with solutions for their entire design and manufacturing space, now Mentor a Siemens business. Okay, so down below, you'll see all of the states that we service, basically the Midwest and the Northwest territory of the United States. So if you fall in one of those and you're not exactly sure who to talk to or you'd like more information, please feel free to reach out to me. I can get you the correct contact information for the person that can help you out the most. Okay, so we are also pairing this webinar series with TriLogic, and TriLogic is our counterpart, or Oasis Sales counterpart in the East Coast and the Northeast side of the nation. Okay, so they're based out of Andover, Massachusetts, and they have been an EDA reseller for over 30 years. So again, they're very happy to work with you in order to get you the correct solution, inform you on the current solutions out there today, and also help you through the design process. Okay, so if you fall into those states down below, again, that East Coast and Northeast side of the nation, please feel free to reach out to me. If you don't know who to contact, I can gladly get you the correct contact information and any other information that you might need. Okay, so here's just a graphical representation. Again, Oasis Sales, Midwest and Northwest, TriLogic down in the East Coast and the Northeast side of the nation there. Okay, so if you like what you see today, we do have currently running webinars, quite a few a month. So if you like what you see, please feel free to check out both Oasis Sales YouTube channel as well as TriLogic YouTube channel in order to find all of the webinars that we have done in the past. So you can kind of see down there below, we've done hyperlinks webinars for signal integrity and other type of analysis on printed circuit boards in the pad space as well as Xpedition space. Okay, so both TriLogic and Oasis Sales allows you to view all of our archived webinars on our YouTube channels. I will throw a quick tidbit about my next webinar. I will be hosting my next webinar on Thursday, June 6th, just about a month from now, the exact same time. And what I'm going to be covering there is how to set up PAD's professional constraint templates and layout templates. Okay, so constraint templates allow us to preserve our constraints in the constraint manager from design to design, as well as create layout templates to make sure you're starting off with the same stack up information for the similar technologies that you might be utilizing in your printed circuit board design. Okay, so here's my contact information. I recognize a few names in our attendee list, so thanks for attending. But if you have any questions or would like to just discuss what we see today a little bit more, please feel free to give me a call or shoot me an email. So you can jot that down, maybe take a screenshot, and I will be showing my contact information again at the end of the webinar today. Okay, so just so everyone knows, I do have everyone muted currently, just to eliminate any extraneous noise that we might be hearing. So if you have any questions, please feel free to write those directly into the chat box, and I will be monitoring that throughout our webinar today. So if I see something that's really relevant to what we're discussing, I can definitely delve into some all topics like that. Otherwise, I'll definitely follow up with you in the next couple of days just to get you the information that you asked about. So hopefully you're all able to see that chat box in the GoTo webinar client. Okay, so without further ado, let's actually hop into today's webinar on schematic analysis. Okay, so if you're unfamiliar with Mentor Graphics solutions for printed circuit board design and simulation and analysis, here's our family tree of the EDA tools that Mentor Graphics really offers. Okay, so we'll mostly be talking about Xpedition today, and that is an enterprise printed circuit board design tool, very powerful layout tool, as well as correct by construction library and schematic design throughout there. Okay, so why Xpedition is powerful is it allows teams in multiple locations to collaborate with each other and allows for very high-end data management capabilities. Okay. PADS has been a very long staple in the printed circuit board design community. It's more of a project or desktop-based PCB design tool, still a very capable tool on outputting some very high density or high technology need boards, but just doesn't include those concurrency capabilities and data management capabilities that Xpedition would offer. Okay. So hyperlinks, not going to be talking about that at all today, but hyperlinks is a family of tools for PCB analysis and verification for issues like signal integrity, power integrity, as well as certain EMI issues that would cause radiation throughout your board. Okay, so that's kind of all on the design side of the printed circuit board, and then we have Valor more on the manufacturing and assembly side of the printed circuit board design cycle. This allows you to bring in an ODB++ file from any design tool and check it for common manufacturing errors as well as assembly errors that would allow you to increase your yield after running it through Valor. Okay, so why is schematic integrity analysis important? Okay, so I like to show this slide off. I usually do it on most of my webinars, and it just does a good job of showing how the PCB market trend has been going over the last few decades or years. Okay, so the main takeaway here I want to show is that red highlighted line on that graph. And what that is it's the average leads per square inch. Okay, so that is just almost exponentially increasing. Our components are getting smaller and smaller. We're adding more and more functionality onto our printed circuit boards these days. It just shows that boards staying roughly the same size, maybe getting smaller, adding more components and functionality, more connections throughout our schematic, much more difficult to visualize or verify visually. Okay, so that's why we might want to think about performing schematic analysis in order to catch those types of errors, maybe for just wiring things up incorrectly, can be very difficult to find if we're not running it through some sort of verification. Okay, so why would we want to do this? So 78%, this is all from Aberdeen, which is a third-party kind of consulting group, as well as they perform polling throughout the business industries. They say 78% of all projects experience 2 or more respins, okay? And like I said, back to that last slide, we're getting more and more leads per square inch on our designs. So electronic designs are getting just too complex to verify manually or visually. If we are trying to manually verify all of our schematic nets, it can take a lot of time. I've seen people print off PDFs, do highlighter comparisons, get the Netlist, do highlighter comparisons in there. That takes a lot of time, and hopefully I'll be able to show how today we're able to actually kind of eliminate all of that through using schematic analysis. Okay, so these schematic errors are kind of passed into the layout, very difficult to find, and if we do find them late in the design cycle, that could cause us to do a lot of rework, ripping up traces, changing components even. That can cause a lot of issues there on the back end. Okay. And like I said, it's usually a manual highlighter process or schematic review process can take a lot of time, and hopefully we'll be able to see how this could eliminate some of those issues. Okay, so what and how are we analyzing our schematic? Okay, so the biggest issue here, again, all we need is a bill of materials and a netlist from our design tool in order to perform this analysis. Okay, so how do we analyze this? we are actually looking at the data sheet of our components used on our schematic, okay? So for example, here, we're just looking at step-down converter from TI, and we'll actually be building the model. We'll look at the output voltage here, for example. So we're going to be calculating that V out is equal to R1 over R2 plus 1 times that 0.8 factor. Okay, so we're getting a roughly that V out needs to be around 2 volts. We'll look further in our parameters in that data sheet, and we'll see that VCC is 2 volts. The minimum of that output voltage is going to be 1.9. Okay. So looking at the actual voltage regulator output, we can see that we have a range of output voltages throughout that component. Obviously, we can accept input voltages on a range, and will also be having output voltages on a range. Okay, so within the models, we'll go into the model creation a little bit once I hop into the tool. We're able to actually edit these parameters and put these parameters in there for minimum input range, output, as well as maximum voltage input and output. Okay, so we're just enabling first pass success with schematic analysis. Okay, so what this is a fully automated tool that will allow us to hopefully replace that schematic inspection. Okay, so while we're running the analysis, while we're doing it in real time today, it will show that it's going to be running over 40,000 checks on all of our nets in the design. I guarantee you we're not going to be able to do all of that through just visual inspection. Okay, it's going to catch parametric errors. It's going to highlight poor design practices and give us warnings of how we need to change those. Okay, so just those bold points on the bottom there, we have works with all major EDA tools. Only that Netlist and the BOM are required. And if you have one takeaway today, I think that's what we want to hear today. Okay, no additional infrastructure, and all of the libraries of base models are included. That really can help because the model creation can be a little bit tricky, especially if you're utilizing 1,000-pin FPGAs, for example. That would be a much more difficult model to create, and we have most of those already in a library for you. Okay, so just some common issues that I'd like to highlight that we can find typically in the manual schematic review process. Okay, so components not properly connected to power or ground. We can typically find that pretty simply in a visual inspection or using a verification directly within the schematic capture tool. Most schematic capture tools these days are able to catch these types of issues. Okay, missing power, if there's just a floating pin, usually that's kind of what we check first in a manual schematic review. Diodes oriented the wrong way with the anode, perhaps wired up to where the cathode should have been. Nets missing the receiver. Voltage mismatch with different voltage thresholds. This can be a little bit more difficult because we have to actually know intelligent component information to catch that. Okay. One thing I haven't highlighted today is wrong board-to-board connections. We can highlight that in manual schematic review. The schematic analysis tool allows us to actually have multi-board analysis. Okay, so in the example I'm going to be showing today, I have a multi-board project, and we can actually verify the connections going from daughter board to motherboard through the connector that we have defined. Okay. All right, so just some of the key features within the schematic analysis tool, and that's just a screenshot of kind of what it looks like, the results, for example, on the right-hand side there. So what there's over 125 built-in automated checks that are going to be ran on every single net if we choose, okay? So it runs very quickly. We don't have to run every single check if we're just concerned with active checks of our active components like BJTs or other types of transistors. Or we can run everything on discretes or just ICs or certain types of nets, okay? So like I said, there's over a library of over 6 million intelligent models included with this package. So of course, even with a very vast library of 6 million models, whenever we're using a new component, we might actually have to create them ourselves, okay? So we have the ability to create those all directly within the tool. Okay, so like I said, it's going to do 100% of those nets in the schematic. It's able to look at multi-board interconnect and do the analysis through that interconnect. Very easy to set up and intuitive operation. This tool is very simple to work with. The most difficult part with this tool is that model creation, and I'll talk about that a little bit further. Okay, so after we've ran these results and maybe found some critical errors or just some warnings that we might want to take a look at a little bit further, we're able to generate a report and use that in our design review process and really simplify all those schematic errors that we might have and very easily look at them through there. Okay, I do not see any questions in the chat box. That's totally fine. Just want to make sure that everyone is aware. If you guys have any questions or want any more information, please feel free to type those in there. Okay, so there's basically two different ways that we can actually provide this software for you. So first is actually buying the software. I didn't have a slide on that. I thought that might be apparent. Then there's also the ability to service or have Mentor Graphics services run the simulation or the analysis, the model creation, and the report generation for you. Okay, so that can be on a project by project basis. They can take your schematic or your netlist and your bill of materials, create all of the models that they need to create for you, run all that simulation, and then generate the report for you. Okay, so again, it's going to identify hidden errors. What it also does is it actually does derating analysis for all of our capacitors as well. Okay. So two options again, just in summary, for purchasing this tool. We can purchase it outright, or there are services. If you're apprehensive about that and want to just understand what it can check, Mentor Graphics can run this analysis directly on your design on a one-off basis. Okay, so again, I was talking that it works with any design tool, but I will be showing today directly from Xpedition Designer. Okay, so Xpedition Designer, otherwise known as DX Designer, kind of Mentor Graphics schematic capture tool for all their PCB layout tools. You can see in this screenshot here, I have a drop-down for Valydate. And what this will allow me to do is launch Valydate or the schematic analysis tool directly from our schematic capture and open up the project that we've been working with directly. Okay. What's even nicer than this is that actually when we're utilizing Xpedition Designer, we can select an error or a defect or a warning that the actual schematic analysis is found, and we can cross-probe directly back onto that net or onto the component or to the pin, whatever that error would be. Okay. I think this last slide, so this is just some of the errors. So again, over 145 errors, checks that it will be running on your schematic. These are just some of the checks that we'll have. Okay. So some of the ones that I wanted to highlight, I put in bold. Pin parametric verification for maximum, minimum, and logic thresholds. Okay, so this is probably one of the more important checks because almost impossible to do in just schematic review unless you have all the data sheets sitting right next to you, looking at the driver output voltage, looking at the input voltage on your receivers, for example, and comparing those to make sure that everything has those correct voltages hooked up for us. Okay. I do see a question from Hoy Tron. Thank you, Hoy. Can I have a copy of the presentation? Yeah, I will actually be, I'm recording this session right now, and again, this will be up on our YouTube channel. And if you'd like any more information, please feel free to reach out to me on that. Okay. So full multi-board backplane interface verification, we're able to define the connections between different boards or the backplane itself and verify the nets coming and going between those boards. Okay. Diode orientation verification. This can be just so simple, such an easy thing to mismatch. This would also work for polarized capacitors, for example. If we set up or incorrectly put those into the schematic, the diode, that could shut off a whole section of our printed circuit board. So that simple check can be very powerful. Okay. Power and ground plane connection verification. This just ensures that all of your power pins are connected to the correct reference voltage that they need to. Again, going from that data sheet, it knows exactly what voltage it needs. It will look at the voltage or the power supply and make sure it's connected to that or to ground. Okay. And then the last one, multiple or missing power supplies on a net kind of goes hand in hand with just what I talked about. And then net's missing a receiver, kind of just like a dangling net. Could be kind of easy to pick up. Usually most schematic capture tools have functionality to catch those directly in the schematic capture tool. But again, if you're not utilizing that or you don't have your library set up to work correctly with those types of verification, we can do that within this tool. Okay, so enough of the slides. Let's actually hop directly into the tool and take a look at this. Okay, so you'll see here, I am going to be opening up the correct project here, and this is our Xpedition Designer Schematic Capture tool. I'm not going to go into any of the capabilities within here. If you'd like to learn more, I have got quite a few webinars on the functionality in here, and you can always reach out to me for more info on that. So basically what we have is we have a multi-board project. We kind of have some logic on this first page, and then some memory on the second page. Okay, so that's all that's going on in this project. And then I do have the other board that this is connecting to opened up in a separate instance of DX Designer, and we can see this is kind of a CPU board. So connected through a connector, and we're going to be verifying all of the nets going to and from both boards here. Okay, so like I was saying, if I look on my toolbars up here at the top of Xpedition Designer, I'll see a Valydate. So Valydate is kind of the surname for a schematic analysis tool that we like to use within Mentor. So you'll see I see Launch Xpedition Valydate. And that will actually launch the schematic analysis tool that we are going to be running through here. Okay. I'm going to open up that recent project that I've been working with, and we can see in this Projects tab just some useful information on the project that we have set up. Okay, so again, the first thing off the bat here that I want to see is we have two boards, multiple boards in this particular project. Okay, I have status, BOM, and both Netlist have been imported. So if I was just working with a different type of schematic capture tool, all I would have to do is hit Update Netlist here, and allows me to point to like an ASCII netlist that I've exported from my design tool, and then a BOM. And typically we would work with CSV. This is probably the best format. It can accept some others, but I usually recommend working with just CSV here. Okay. And then the connectors, you'll see that all I've done here to define the connector is basically placed the connector name. Okay, so that connector resides in both of my schematics, both the Turbo T and the expansion schematic that I have here. That connector name exists, and it's going to match up those pin numbers because they're going to be, they have the exact same pin numbers on those schematics. Hi, Dave. I see a question from Dave Rosenberg. He says, is a special license necessary to have Valydate with Xpedition Designer? Great question. There is no extra or special license necessary in order to get the interoperability between Xpedition Designer and the Valydate or schematic analysis tool. If you own a license for both of those, they will automatically work for us. And if I just go, I wasn't going to plan on showing this, but if I go to my preferences, you'll see there's an Xpedition Designer tab where I am actually pointing to my install directory, and that's all I have to do in order to enable them to work correctly with each other. Okay, and then just some other things that I wanted to point out here. You'll see in my project here on the left-hand side of the schematic analysis tool, we'll see in the Turbo T, it gives us that 759 components are used, and there's a total of 613 nets. And then the expansion board that we actually took a look at in the Xpedition Designer space, there's only 16 components and 93 nets, and it kind of shows the connections for those as well. So just a good overall information on our project that we're working with currently. Okay, so we've imported the BOM and the netlist for all of our boards so far. Now, what we have the ability to is actually look at those BOMs. Okay, so you'll see at the top, I can filter for which board I want to look at for just this expansion. For example, again, only 16 components, and on the Turbo T, we have 759. So just kind of shows those without. Update all models. That would again look at our library of 6 million parts and assign the correct model. And this would all be based off of the model part number. And what that is basically is the manufacturer part number. Okay, so it's going to be utilizing the manufacturer part number and look at the library and match those two up. Okay. BOM part number, that's just going to be your company part number that you use when you place that part on the schematic. The ref des, of course, we have that information from the BOM description. Application specific, that talks about if this this model has been updated specifically for this project. Okay, most of them would always be no, but in case I wanted to change something on a one-off project basis, I can do that there. Okay, so just to take a quick look at what the models look like, we'll look first at a resistor. I'm going to right-click on there and just hit Edit Model. There they come. All right, hiding back here. All right, so this is just a capacitor model for us right now. Very simple. Discretes are very simple to model and understand. I just wanted to start there. Okay, I'm sorry, this is a resistor, not a capacitor. So basically all we have here is the pin numbers and the pin names, okay, and the value on all of there. Okay, so discretes, really this is not polarized, it's bidirectional for both pins. Pretty easy to set up and understand here. Okay, but if we wanted to look at a little bit more of a unique example, if I went down to maybe an IC of some sort in this project, I can right click on here. This is a MOSFET. I'm just going to hit Edit Model one more time. Not sure why it's opening up in the back for me. And this gets a little bit more unique for us. Okay, so this is just gate, drain, and source information on this MOSFET. We'll see again, we have the pin numbers, the pin names that are coming over from those symbols, and then the pin type, like a FET gate, FET drain, and FET source. Okay, so really all we're having to set up in this, because it's going to be actually connected to drivers, is going to be our gate in those MOSFET models. Okay, so we have an input maximum voltage, the high and the low as well. Okay, so that's basically all we've set up here. MOSFETs, pretty simple as well as far as it goes. So I just wanted to show one more type of model that we're going to be working with, and that would be, let's just go ahead and take a look at a flash memory. Okay, so this one has a lot more information. So this is kind of more the power of the schematic analysis tool. Okay, so it has an input voltage that really we are able to set up utilizing VCC. Okay, so within the input high and input low, directly from the data sheet, we will see the requirements that it is 70% of VCC would be the input high and 30% would be the low input on there. Okay, so this information, again, going to be really difficult to look at the schematic, understand the data sheet information, and then actually go ahead and make sure that it's hooked up correctly, all with visual inspection. All right, so that's kind of our models, and most of these were directly brought down from that 6 million part library, and I don't really have to do any model creation from that. All right, so once we have set up our all of our models, I can go ahead and take a look at the net list. Don't really have to do anything within here. This just is brought in during our project creation. Net lists for both that Turbo T board and expansion board. I can see all of that net list information directly within here. Okay. The next thing that we do have to set up is our voltages. Okay. And our different voltage or power rails are all defined within here. Okay, so if I hit scan, for example, that's just going to go ahead and look through all of my nets and all of my net names in the design and automatically assign the Vmax and the Vmin on those voltage rails, again, due to the model setup that we have. So all of our power supplies are automatically going to have models based on the component that we place on the schematic, and it's going to give us like the V maximum and the V minimum output of our 1.8 voltage source here. Okay, just some useful information within here. It automatically flags here, so you can see this little caution symbol. It will automatically flag if there's a difference greater than 5% of Vmin and Vmax between that output voltage. Okay, just to show us there that there might be an issue, just to take a look, make sure you understand. Okay, so once we've had actually set up all of our voltages, we can just go ahead and actually look at the Run Manager tab. Okay, so within the Run Manager tab, here's where we actually set up our test cases that we are going to look at. Okay, so here's all my different categories that I wanted to look at. Active would be errors related to active devices such as transistors or ICs, FPGAs, anything that's actively working in a circuit. Passives, of course, just our discrete modeling. We have specific tests for that. So capacitor fails derated voltage, floating capacitor found, that type of information. High value resistor possibly used as a series resistor. That could just be an error on selecting the correct value component in a series resistor. Okay. To look at some of the voltages on the power, ground pin connected to a voltage rail, shorting ground directly to voltage to explode or create some blowing up components on our board, that'll find that directly within there. Multiple power sources, net voltage is less than V high on the input. So again, there's over 140 checks that are being checked within here. Unfortunately, I can't go through everything today. Okay, so if I don't have everything set up, I just want to run, let's run active, passive, and then just these four. Okay, so we're going to be running tests on the active components that we're utilizing, passive components, and then the power thresholds and the voltages themselves. Okay. What I also want to set up is the extract the derating information on all of our capacitors. Okay, so if I just select that, it's going to generate a report based off of our capacitor derating setup. Okay, and of course that opens up in the back as well. This is our configuration that we have set up for our capacitor derating values. Okay, so it allows us to set up the derating percentage based on what type of capacitor has been used, as well as a resistor power scale factor here as well. Okay, so I can edit schemes for different types of projects that I'm utilizing. I'm just using the default scheme. You can save those off and utilize them in further projects. Okay. So I have selected only 4 of those. I'm going to extract the derating information. Basically, now we've done, so far, all we've done is import the BOM, the Netlist, set up our voltages and models correctly. Now we are ready to run that schematic integrity analysis. So this is going to be real time. I'm just going to click on this. Voltages may not be complete. Do you wish to continue? We went through those voltages, so I'm fairly confident everything's set up correctly. So I'm going to hit continue. So some things to note while this test or analysis is actually running. In the bottom right-hand side, we've got statistics. We'll see that total tests performed is just constantly increasing. Okay. Up at the top, it shows us what pass is happening right now, 104, and the number of nets that has been tested as well for us. Okay. So this shouldn't take too long for us, but we'll see on the, and then on the top right-hand side, we have the actual results. So critical errors are going to be things like power pins connected incorrectly, input voltages not defined correctly or set up correctly to the actual power source. Okay, defects might be defects in the setup or in our modeling that we can take a look at. And then warnings are going to be things that the tool does not identify as a critical issue or error that will essentially allow the schematic to still operate, but maybe not a best design practice for us. Okay. So we're about 50% of the way done. Again, shouldn't take too long. I'll just start scrolling through some of these. We can see some of the defects that I have already I can look at this while the analysis is still running. So the driver U2 versus the receiver has higher output maximum voltage than the V in max. Okay, so we're getting over 10,000 volts, and the V in max is 3.4 volts. So maybe we have a voltage divider set up very incorrectly wrong. We can take a look at that. And again, what's really nice about these results is we're able to cross probe directly back into the schematic within Xpedition Designer. Okay. So we'll also be getting bad data. So max threshold missing on S13, and in the parentheses on Turbo T versus the other board name, that's just the schematic name that we're actually looking at. Okay, so now we're on pass 2. It's moved from nets to now checking all of our components, and we'll see that we're almost to 80,000 total tests performed on our schematic. Okay, so definitely not going to be able to check all those type of things just visually. Okay, and then basically we're checking the pin mating in the last pass here between the different boards. All right, so basically we're done here. The only warning I got was the derating file already exists at list location. Would you like to overwrite? And I'll just say yes. Okay. All right, so after those checks, I've only checked the active, the passive, and then the 2 voltage checks. We got 14 critical errors, 433 defects, maybe missing model information, and then 60 warnings. So really the only 2 things that I'm super concerned about are 14 critical errors and 60 minor errors or just warnings. Okay. So that helps with us, but what I want to do to make things a little bit easier to actually see is I can go to my intelligence results processing. Okay, what this does is, again, it looks at all of the errors and defects and warnings and just runs a little bit more analysis on them to actually make sure that they are an error. So I'm just going to run the intelligent processing, and it also kind of color or highlights them, makes it a little bit easier for us to look at. Okay, so hopefully it will look at all those critical errors. What it can do is it will eliminate a lot of the false positives that may be highlighted during our first analysis. All right, so while this is happening, we'll take note of those critical errors versus warnings and defects. While it's open though, while that's running, I'm going to go ahead and just open up that derating. All right, so I'm going to open up that derating analysis that we had, and it generates just an Excel file for us. Okay, so pretty easy to understand this derating results. So this can really save a lot of time in this analysis phase. I've seen a lot of people take many manual hours on doing derating analysis on all of their capacitors on their schematic. This basically, again, took all of our capacitors, allowed us to set up that model information correctly, looks at the data sheet. We set up our derating thresholds again in that analysis setup. And now this just gives us a great report showing the derating percentage. That's what we set up in our initial setup there. The manufacturer part number, what type of capacitors used. Ceramic, I think, is probably the only kind used in this design. And then the value of that capacitor, the tolerance, the net name that it's connected to, and then the actual percentage used of that capacitor derating. Okay, so we're going to get a pass-fail as well. I don't think I have any fails in here. I'm getting some NAs just because the setup might not have been correct on those particular models. Okay, so hopefully that will alleviate some of the time used on the derating analysis that we typically go through. So let's hop back into the Valydate tool and actually see if our intelligent run processing is fixed. Okay, so looking back at the results tab, we had 14 critical errors after running that intelligent results processing, which tries and eliminates false positives. we're able to see that it eliminated 3 critical errors for us. Okay. So I'm going to filter this and go down to the critical section, and we're just going to focus on those today. Okay. So again, 11 critical errors here that may not allow this circuit to work at all. I'm going to go ahead and expand the description for us so we can kind of look at that a little bit better. We'll see which board this particular error is on, and this one, for example, is on both the Turbo T schematic as well as the expansion schematic. Okay, so 2 outputs are attached on net UART2 at this reference designator pin on Turbo T and on U2 pin 9 on the expansion project. Okay, so if I wanted to take a look at that, so 2 output nets attached to that UART. So our UART communication protocol probably is not going to work if we have 2 outputs attached to them. So what I can do is I can say view net in Designer, as in Xpedition Designer, and I am actually able to click on either board and highlight that directly in the schematic. So I'm going to click on that and hop back into the schematic. And we can see that this is that UART net line. It's already been selected for us. The page was opened up in the schematic designer. What I can do here, just some fancy features that have been added in the last few releases, I can trace that connection. And it's going to show everywhere that that particular UART net has been connected to. Okay, so I can click on these and do some debugging to figure out exactly where my 2 outputs have been made on that particular net. Okay. If I hop back into the Valydate, we can just look at a few other critical ones that might be interesting to look at. Okay, so pins U2 on the Turbo T board are defined as power pins. So that is important because they're coming again from the data sheet. They're defined on the data sheet as power pins, but they're not connected to the power source on DRAM VDD clock. Okay, so our DRAM isn't connected to VDD essentially. And what I can do one more time on there, I'm going to go ahead and view net in Designer, click on that there. Wrong design, and it's highlighted that DRAM VDD is not connected for us. Okay, so we just have to figure out why that's not connected to the power correctly, and it actually looks like it's just not making that connection for us for whatever reason, and I can go ahead and fix that. Okay, so that's just kind of a general overview on some of the errors that we have. What I can do is I can export these results as a CSV type format, or I can generate a report, and I've gone ahead and done that, and I'm going to open up the report I created in that PDF viewer. Okay. So here's the schematic analysis report. Gives us just the project name, the company name, the division, everything that you have in there. And it gives us basically a nice summary on what a defect is that will or likely cause damage to or functional disruption to the actual board. Okay, so I can scroll down and it puts all of the critical defects for us first. This could be really useful for if you're not utilizing Xpedition Designer and don't have that cross-probing capability back directly into the schematic. We're able to review all of these in a PDF or in Excel if I wanted to just export those as Excel as well. Okay. All right. So that was all I was planning on showing today. I don't see any other questions in the chat box. If you do have questions, please feel free to write down my contact information and shoot me a message, give me a call. Always happy to help or get you the correct contact of someone that can. And just my last thing before I let everyone go, just to save the date for my next webinar is going to be, again, Thursday, June 6th, same exact time as it was today, on PADS professional constraint templates and layout templates and how to utilize those correctly. Okay. All right, well, so thanks everyone. So I do see another question with Chris Bricker. Again, I got that question a few times on how does the licensing work with DX Designer. So DX Designer is licensed totally separately by itself. You don't need anything but an Xpedition Designer license. And then to actually run Valydate, the schematic analysis checker, you need just a license for this tool, okay? There is no extra license to allow the interoperability or the cross-probing back and forth, okay? So all you need licensed for that to work is Xpedition Designer, and then the Valydate or schematic analysis tool, and then the interoperability will work there here, okay? You don't see it in VX 2.3, great question, Dave. That is because, first of all, you have to be running Xpedition 64-bit. Okay, so if you're not utilizing Xpedition Designer 64-bit, I would take a look at that. And then you do have to be utilizing VX 2.5, the most current version, in order to have the drop-down within this tool. Okay, but even on VX 2.3, if you just download the 64-bit version and have Valydate RAM the tools, we would still be able to cross-probe, because within Valydate, you're able to just set the install location directly to where you have Xpedition Designer work. You wouldn't see this drop down again in VX 2.3, but you would still be able to cross-probe back into it. Okay. All right, so hopefully that answered your guys' questions. I don't see anything else. I'm going to end the webinar here, but please feel free to shoot me an email, give me a call. Hopefully everything was some good information today. Really appreciate everyone attending and hope to see you in a future webinar. All right, thanks. Bye-bye.